the link the dots between the whole complete picture, what's going for in terms of your drones. Then JMA, the company, has worked tirelessly to raise the awareness, provide the infrastructure support, test the site access, skilled aerospace workforce, business solutions, investment access, government licensing, and a foster industry academic collaborations. And the company has partnered with EVA from Germany, Vector 3D in Australia to bring a cutting-edge aerospace technology to the India. And the company has conducted more than 200 workshops, professional talks, webinars, and seminars, numerous top engineering institutes, colleges, and about the organization to help give an insight into the aerospace sector with a particular focus on drones. JMA is also a member organization of the Drone Federation of India and actively participates in regulatory framework discussions. Sir, I welcome you for this webinar.
Thank you so much.
Sir. And I welcome Dr. Y.T. Krishnagowda, sir, Principal, MIT, Tandavapura, and Dr. S.M. Shashidhar, sir, Principal, PDIT, Vijayanagara. I welcome you both of you, sir, for this webinar. And I welcome HODs of all the departments, teaching and non-teaching staff, and my dear students of both the colleges for this webinar. Flying is more than the sport and more than the job. Flying is pure passion and desire, which fill a lifetime. Let us dream to fly high with gaining the knowledge of from this today's session. I welcome you all for this webinar. Sir?
Thank you so much for that introduction. It's indeed a pleasure to be talking about UAVs again. It's something that I've been doing for almost 10 years now. And this started right back in college, way back in 2010, when I started building model aircrafts, radio-controlled model aircrafts to understand how aerodynamics and flight controls work. And today, my business, my passion, and my hobby all are in the unmanned space. Very few people have that in the world, and then I'm privileged to be seeing that. We will go into the topic. This is a very challenging topic for me as well, because the parts in UAV communications have been evolving very drastically. And this is something that we are also learning as we talk to OEMs across the world who are manufacturing drones, including drone taxis. And with that, we understand the amount of encryption, the fidelity that is required, the latency issues that they face. There are a lot of challenges, but then since we are evolving very fast on the 4G and 5G space, tomorrow drone delivery at your doorstep will become a reality. And Karnataka is the UAV capital for the country. We recently finished trials for medical drone delivery. Almost 50 hours of trials have been done. On multiple fronts, we have been in the forefront of drone development in this country. And today, post the attack on the Jammu Air Base, we are also in the forefront of developing anti-drone technology, which I will try to cover in brief, because this is something new that has now surfaced in India, which existed in the world, but then now surfaced in India and is in high demand. So let's go ahead. Next slide, please. Next slide. So how I do my presentations is I don't have a lot of words on the presentation, is more of videos so that you could see what's happening out there in the world and understand. Today, with swarming technology, with access to 4G and then testing happening in 5G, as well as satellite communication, I can sit in this room and control a drone as far as the other side of the world. That's today possible. And when we started aero modeling way back then, 2.4 gigahertz ISM band transmitters were the only things available. And when my seniors started, or our instructors started, you would only get crystal based devices that could communicate, but then would never get range, and then there was always a problem. But when aero modeling even started way back in 1930s, and radio technology was still developing, uh, transmitters would be as big as the chairs that you sit in today, right? And today, it's come down to controlling a drone in your watch, not even phone. I'm saying it's possible on your watch. If you have a smart watch or an Android based watch, you can control drones in that. That's how much we've developed. Military drones are flying in another continent with the pilot sitting in another continent altogether. And this has really transformed the way the world communicates one place, the way the world sees itself, and how warfare happens. Let's take a look at some of those. This is only an eye opener session. I am not an expert in UAV communications. I am also a student still. I'm still learning. It's too vast I think, for anybody to call themselves an expert in this, because the changes happen on a second basis. So let's take a look at what are drones. Drones are basically any unmanned vehicle that have three basic components. One is the flying vehicle, then second is the ground control station, and third is the command and control link through which we control the drone and also transfer and receive data. Now, this full three parts together is called the UAS, or the Unmanned Aircraft Systems. But recently, the definition has also taken a little bit of a change. Drone now predominantly in India means unmanned aerial vehicles, those vehicles that are not manned and fly. Uh, and drones today have 200 plus applications, and because of that, communication is key, and plays a key role and is very critical in how efficiently and effectively we use these drones for those applications. Next slide. There are different types of drones or UAVs. The most common one that we would have seen is the multi-rotor, but then these are the basic 6 types. We have the fixed wing. This is how it all started. And then we have the single rotor or the helicopter drone. And then we have the more stable multi-rotor platform. Then we have a hybrid version of the fixed wing and multi-rotor called the hybrid VTOL. And we have next the ornithopter, that's something that flies like a bird. It's a very interesting concept. And then we have the aerostat. Now, the fixed wings advantage is that it can fly for longer distances. It flies like an aeroplane itself. You either need a runway or a catapult launch, or you will need to hand launch it. And then for landing, you can either use a parachute to land, or you can use a runway to land. So this is one of the major advantages as well as disadvantages. The single rotor or the heli has the capability for vertical takeoff and landing. It's more agile and more fast. Uh, but in terms of payload to size ratio, more the payload, the larger the helicopter becomes. The multi-rotor, whereas on the other hand, is a more stable platform with even power distribution and can carry larger payloads for shorter span of time. That's advantage and disadvantage. But then it has the vertical takeoff and landing capability. Now, when you need a longer range and endurance, but then you don't have a runway, then you go to the hybrid VTOL, majorly used in surveillance space because of its ability to take off and land vertically, but also its ability to have high endurance or longer flight times. And this is now majorly used in the military segment for surveillance. And next we have the ornithopter. Original design dates back to Leonardo da Vinci, but today we have this on multiple use cases. If you've seen the movie Uri, you would have seen this. This technology actually exists. The one that you see in the picture is used on large scale farms where a single farm holding is 5,000 or 10,000 hectares to scare away birds, because scarecrows at this point of time really don't scare birds. So they're using this. It's designed after a predator bird. This is a peregrine falcon design, and that's a predator. And because of that, it becomes easier to scare away other birds, and it's more efficient. And also, you will be able to understand or get data analytics on the type of birds that come to the crop, right? And they also use this bird or this ornithopter at airports to scare away birds again, so that bird strike is avoided for the aircraft. So that's another use case. Aerostats are basically balloons filled with helium, work on the concept of buoyancy. The major advantage of this is longer flight times. It can stay up in the air for a really long time without consuming much power, but it's not fast. So if you have static surveillance over a region, then aerostats are the UAVs to go for. Even it applies for sporting events where the event goes on for a long period of time, for 2 hours or more. So these are the basic configurations of drones that exist, and there are more variants that come up. Like in the helicopter variant itself, you have syncopters, tandem rotors. Uh, you have different concepts that have now come up, but then these form the basic types of drones. Next, please. UAV communication. So initially, when it did start with radio frequency transmission over started amplitude modulation, and then we had frequency modulation also come in later. But it was slow. Initially, it was mostly tethered. There would be a wire connected to the UAV. I'm talking World War One and World War Two times. Right? You would have wires connected to the UAV that would help in controlling it, or you would have radio communication, but then you would not have a longer range. So this is how it started. And later, as time progressed, when ISM band, the Industrial, Scientific, and Medicine band, that's the open spectrum or D-licensed frequency band of 2.4 gigahertz and its variants, and 5.8 gigahertz and its variants. So this is when it really opened up, where a lot of companies could start R&D work, because any other frequency band, you will need a Ministry of Telecommunication permission, and that also means you will need Ministry of Defense permission, and that's a very long process. That's majorly restricted to UAVs in the military space. For the commercial and hobby space, the ISM band is used. 2.4 gigahertz is generally used for control data transmission or telemetry data transmission, and 5.8 gigahertz is used for larger data packets for video transmission. So this is how it started. Uh, you would is majorly frequency hopping method by which signals are sent to the drone, and you have different types of receivers for terrestrial as well as for airborne. We majorly use airborne receivers, and we also have long range telemetries for which you need permission, the 400 megahertz and the 900 megahertz bandwidth. But with the 900 megahertz bandwidth, you can get data or smaller packet of data for up to 40 kilometers. So this is generally used for beyond visual line of sight applications to get telemetry data. Video data is not possible in that frequency range because of the high energy consumption. But with this advancement today, you can have anybody can buy a drone. So that's the use case. And then a toy drone costs as less as 2,000 rupees. When we started to build something like this, would easily cost us a lakh. But today, it's you can buy it off Amazon, you can buy it off Flipkart. These toy drones cost you very less, and then That's all because of mass production of the devices and efficiency of those devices that have helped in this entire scenario. Next slide, please. These are the three basic methods of UAV communication. It initially started with radio signal, then moved to satellite, and today, because of the 4G and 5G availability, you have access to move data through the internet, and with that, we say the range is infinite. And when Elon Musk Starlink goes up throughout the world, I think you will basically you can fly drones on any part of the world using the data link provided by the Starlink satellite constellation. So that's one of the biggest advantages. Now, with satellite data, so everything has its own range. With radio signals, we are limited to what we call VLOS, or visual line of sight flight. It might be 500 meters or it might be a kilometer. We are limited to that. If we push the bandwidth, then we are moving to 30, 40 kilometers, but then we will not get video signal. So we will not be able to see. With satellite communication, again, the range is endless. Wherever satellite network is available, or satellite reach or region of coverage is available, you can fly the drone. So the recent example for this is when they took out General Soleimani of Iran at the Iraq Baghdad airport, just outside Baghdad airport, and the pilot generally is sitting in the US. So satellite communication is majorly to do with military systems, but now with nanosats and cubesats being launched on a very large scale for internet connectivity, we will have commercial drones will have that capability as well. And again, in internet, wherever internet tower is available or internet communication range is available, we can definitely use that. It's very simple. You have the drone, you have an intermittent edge computer on the drone, and then you have an LTE connection, either 4G or 5G. In India, 4G is generally being tested on, since 5G is not full-fledgedly present. And because of that, you can fly beyond visual line of sight and also get video data. That is majorly important when we are flying first person view, or we are flying the drone based on the video feed that we are getting. Next. So this basic block forms what we call the entire UAV communication space. The first space is the drone space. The second is the enhancement space, and then communication based on applications. Now, what does the drone part of it really need for us to have effective communication? One is you need communication modules, be it receivers or transmitters. You need very good antennas depending upon the range and the type of energy of the packets that are being transferred. You need handling platforms. It might be softwares or that help put together everything. Then you need networking. Now, in networking, it's majorly to do with drone swarms, where you're flying 10 or 15 drones together. You need to be able to communicate between drones. Drones cannot communicate to the ground station and then fly. It doesn't work. You'll need to be able to, there will be a master drone, and then you have slave drones. So a drone should be able to communicate with each other. So that network of communication is also required in the use case of drone swarming. Then you need wireless sensor networks, and then vehicular communication systems for transmitting data from the drone to the controllers or the ground control station or the command center. So this is the major communication building blocks that go on the drone's system. Then you have other enhancements that we have. So you can put an edge computer and use AI-based algorithms to enhance this. So one place where they did this is finding people, or finding people lost in forests. So what happens is when the tree canopy is very thick, you will not be able to correctly spot heat signature, because even trees produce thermal output, right? So because of that, you will need AI-based algorithms to pick up the heat signature from a person and then decide that's a person. So that is enhancing, and then that way we will be able to detect the person. So that is also enhancing the data that is being derived from sensors and then communicating it back. The second part would also be using AI for intelligent swarming and as well as intelligent obstacle avoidance. Drones like the Skydio and the Skydio 2 and the Skydio X2 use intelligent obstacle avoidance based on AI algorithms to even fly inside buildings where GPS is denied, right? That way to find its position in comparison to the obstacles around. That's another thing AI is used. Now, navigational technologies also, to improve navigation, we will need better technology to understand where exactly. Now, the normal GPS based on your satellite communication can give you accuracies only in meters. Now, what if you want accuracy in centimeter? Then you will have to go for differential GPS methodology, where you have a base station on the ground on a certain reference point, and the drone communicates with global positioning satellites as well as the ground station to get better accuracies. Now, this is also enhancing the navigation, and this communication either PPK based or RTK based. PPK is post processing kinematics, and RTK is real time kinematics. Now, both of this will help better the positioning, and this also forms the part of the communication system, so that the drone exactly knows where it is. Now, next is security enhancement. Now, today, drones that are using internet or SATCOM can be cracked, but advanced security measures will also help. Maybe a 128-bit encryption and other safety methodologies will also help drone not going rogue because of somebody else taking over the controls, right? This has happened in multiple military cases, but it generally doesn't come out because it's national secret. So that is another place where security plays a major role. Even when data is being transferred, nobody should be able to tap into that data and take. So that way, enhancing communication security feature is also important. Profiling and optimization comes in autonomous operations for inspection, where we use drones. Let's say we are using drones for an application where we are inspecting a windmill. Now, how do you manually flying around a windmill is different. When you have to do it autonomously, there's an optimal way to do it. How far away from the blades you have to be, and then how in what angles to take photos, what photos to take first, and at what lighting to take these photos. This, when you do manually, it comes over experience. But then when we are helping the drone understand it better, that way you will need better systems in your communication that can go from the edge computing to the drone as well as from the ground station to the drone, so that it can perform that operation. Okay. Now, these are enhancements. There are multiple other enhancements when we're doing object tracking or personal tracking. Whom to track? Like, let's say the field of view of a camera is tracking, sees 10 or 15 people in it. But then who's the exact person to track? So this also will mean sending exact data if your edge computer is on the ground, and then that communication needs to be fast. So all of these parameters help in enhancing the communication so that you achieve mission objective. And then in communication based applications, be it surveillance or emergency communication infrastructure, aid, all of this, different communication forms play a vital role. Now, in surveillance, you have both SATCOM as well as radio direct visual line of sight communications. Now, when it is that case, how do you work now when you're doing inspection to a mobile tower? You will have a lot of interference. How do you overcome interference in that case? And when there is emergency aid that needs to be moved, how do you work in that space? So these spaces also look at different forms of communication modules that require will be required for based on their specific mission objectives. So these things or these blocks help better communication and as well as provide fidelity so that the drone is always in contact with the ground control station and the operator so that any last minute decisions can be made based on contingencies. Next slide, please. So we'll take a look at different use cases that will also help us enhance our understanding of what's really happening in the drone space. This is the new Parrot Anafi AI released day before yesterday, where Parrot, US company, has come out with a drone that purely operates in the 4G and 5G space. Now, with this, they have enhanced the access, the drone's capability to fly at different locations beyond visual line of sight as well. Now, let us say you have to monitor or inspect a skyscraper. You can't stand in the ground floor and fly. It doesn't work that way. You will need access to video feed, high quality video feed to even fly that. And here they've incorporated a 41 megapixel camera so that you get HD feed. And that is now possible because the data is being transferred over 4G and 5G networks. Similar to what we are right now doing, right? You can get high quality feed because we are on the internet. If we had to do this with normal radio communication, you would get a lot of grains on the video that you are getting. So the better the packet transfer rate, the better is going to be the video quality, and that's the whole concept that they have based it on. And 4G anyways works between 700 megahertz and 900 megahertz. This is the LTE band. In India, it works at 850 megahertz. And the data transfer rate is also fast. Fidelity in the network is also good. And the software can also optimize the different frame rates so as to be able to get a better view, like how you're on YouTube, and if your network is poor, it goes to 144p or 360p, and then if it's really good, you can actually go to 720 and 1080p quality, right? The same way here, they've also incorporated a software that could help optimize the video feed instead of cutting off the video feed fully. And the most simplest thing is they put a SIM card in the drone, and with that they're able to communicate with the system really well. And with 5G, it's even better. Next slide. Let's take a look at the video. You can here you can see at what altitude the drone is flying. This is basically photogrammetry or mapping as we call it. Now, all of this data being transferred to it, these are all post-processed parts, but then the data that actually comes is through the 4G network. And the other advantage of this is you can also uh, not put a lot of antennas for radio communication, and that means a lot of power is available for the operation itself, and that's one advantage that is there. Otherwise, you will need a longer antennas, either 9 dB or 12 dB antennas, for you to be transferring that amount of data packets. But here, because we are on the 4G, you don't need larger antennas, and that's that way you will be able to make the drone more compact. Next slide. Now with 5G communication, the entire thing gets even better. The data is high speed, low latency. You will not have latency in the video that you get, so that where you're flying in very critical areas, latency may becomes an issue. So I had the opportunity to fly with the National Disaster Response Force in the month of Jan Feb, where we had to fly at Uttarakhand. If you remember the Uttarakhand glacial disaster that happened, and two dams were swept away. So we were flying at 2,500 meters above sea level, and we had to travel more than a kilometer. And with normal radio-based video transmission, after 2-3 kilometers, you will start getting video latency, because signals are getting bounced off the mountains as well. And because of that, when you're flying through very narrow spaces, it becomes difficult to understand where the drone exactly is, because your actual drone movements will be faster, but the video feed that you get will have latency, and because of that, you will not be able to make a effective decision. So 5G will remove that. If we can have towers in those locations, we will be able to perform these operations better. We can also use drones to prevent disasters, and that can be achieved autonomously with the 5G network. Let's take a look at the video. Next slide. Yeah, so that's how they've done. You'd see it's a normal PS2 joystick that they are using connected to their computer, and then the entire control is through the 5G. Next slide. So this is our partnering company in Germany. This is a drone docking station. These docking stations are used for mostly autonomous operations where you will have drones in them, and then when there is a requirement for a specific objective to be accomplished, the doors open and then the docking station comes out, the platform comes out, and the drone takes off. Now, EVA has been working on the 5G space, and they've done POC in Italy as well. And where the entire thing is controlled over the 4G and 5G network, and they're not using radio communication because most of it is drone delivery applications, and hence we cannot only operate in visual line of sight. So here what happens is everything is on the phone, IoT based. So somebody raises a request to pick up a parcel. They even brought in Boston Dynamics Spot, the dog that you've seen all dancing and all of that. So they brought that. That will pick up the package from inside the building, bring it to the docking station. From there, the drone picks up the parcel, goes to the next docking station wherever it needs to be delivered, releases it, and again a spot at that location takes that parcel and then delivers it to whomever it's required. Now, all of this is over the internet, and they have even used multiple drones at the same time to get this done, and then this is seamless. If we had to do this over radio communication, it would have not been possible, and with satellite communication, it would have been costlier. So they've used the internet on the 4G and 5G space to make this possible. Let's take a look at. So we are getting this technology to India next year. This will transform the way lab tests or even access to primary medical care happens in India. So this will be over the internet itself, and that way it becomes seamless to integrate because you don't have to set up a separate communication systems altogether, which is very expensive and time consuming. And by the time we do all of that, we would have passed the wave. So that way integration also becomes very easy with the 4G and 5G space. Next slide. So this is how satellite communication works. Majorly, this is a space where your terrestrial communications might not be able to reach to the drone. Let's say the drone has to fly 1,500 kilometers. Now, in that space, terrestrial communications working seamlessly is very, very difficult. If you have to fly over a large water body, then it becomes very difficult to have continuous terrestrial communication. And that's where satellite communication comes in picture. And it gives you seamless connection. And with satellite communication and satellite triangulation, you will be able to get exact location as well as get data that you are looking for without any interruption. And that also gives you access to longer range for you to fly, and then don't have to always be in the war zone for you to take off and land those drones. So let's take a look at how that's done.
Unmanned aerial vehicles. You are about to realize their full potential. Maritime surveillance, infrastructure monitoring, crop supervision, we need to control and command the UAV in a secured way. Unmanned aerial vehicles are just like planes, but the pilot stays on the ground. The pilot and UAV must be perfectly connected at all times. Thales Aerospace has a solution. Based on space technologies and telecommunication satellites. Using the 5 GHz frequency band allocated worldwide to aeronautical safety applications. Safe bidirectional command and control communication links are established with the UAV. From the remote pilot station through the ground gateway and the satellite payload to the UAV. Or, alternatively, through terrestrial stations using the same 5 GHz frequency band and the same unique onboard terminal. Thanks to the 5 GHz system, long-range flight is now possible, while maintaining permanent control on the UAV. After taking off using a 5 GHz terrestrial station, a UAV can seamlessly hand over to a satellite system for cruise, changing spot beams as it evolves in the satellite system coverage area, even possibly being handed over to another satellite while en route, in a completely transparent way, ensuring a safe command and control link available at all times from takeoff to landing. Thales Aerospace brings to this system several orbital position and fillings that allow the transmission of 5 GHz signals in an exclusive way. Few satellites allow highly available and safe services around the entire world. The 5 GHz system is a breakthrough innovation to push further UAV applications.
Yeah, so that's Thales Alenia concept, but then that's how predominantly it works. And with multiple satellites and better range, you could today now we have the Boeing teaming concept that has also come, where you have unmanned fighter jets flying along with manned fighter aircrafts, and that is also now possible via satellite communication itself. And that's how the entire air supremacy role itself is now changing. And this is all possible because of satellite communication. Otherwise, that would have never been possible. Next slide. This is another future scope where Vodafone and Ericsson are working on to use the mobile network data for operations. Let's just take a look at that.
Ericsson and Vodafone are on a shared mission to enable drones to fly safely and securely beyond visual line of sight. Because it's only then that drones will be able to realize their huge potential. Whether that's aiding routine access in hard-to-reach areas, delivering life-saving supplies to hospitals, or acting as first responders in accidents and helping emergency crews arrive prepared. We know if we can overcome the challenges, drones can help us build a sustainable tomorrow. That's why together we're finding innovative solutions. We're working behind the scenes and making the vast pool of network data accessible to the drone ecosystem, finding ways to ensure they're constantly connected to a trusted and secure network, the mobile network. We're creating models of network coverage up in the air to enable safe and secure route planning, working with SIM technology to identify and authorize flights, and using anonymized data to ensure safe flights by avoiding large groups of people on the ground. And we're doing this by working together and continually testing and innovating to enable drones to fly safely beyond visual line of sight, so we can all take the next big steps into the future.
Also, the future scope in communications will also be HAPS, that's high altitude pseudo satellites, where basically they are drones, but then also act as satellites. They fly at about 20-30 kilometers above sea level, just below the low Earth orbit, and using the thin air, solar powered, and then they can stay up in the air for weeks together. And these drones will act as communication modules for drones flying at lower altitudes. And this is another technology that's being developed in Airbus. And that is also going to transform the way communication happens. Because launching satellites are costly affairs, and then they create a lot of space garbage after their life is done. But with the HAPS concept, you can bring back the drone, service it, and then again launch it. And it's very cost effective as well. And then it's fully green. There's no fuel that is being burned to put the satellite into space. So this is another front where these technologies are evolving to help drone communications and data transfer become more easily accessible, have high quality and high fidelity, so that more and more applications in the beyond visual line of segment is possible. So I think we are done. Small words about JMA. I think they did mention in the beginning. 2019, I started this company with the understanding that there needs to be somebody who could help the UAV industry in India to scale up. That was the primary aim, and then we've expanded our services to the multiple offerings for even aerospace companies. Next slide. Next slide. So these are all the services that we offer at this point. We do infrastructure support, skilled manpower support, business consultations, investments, government liaising, QCI compliance consultation for drones, R&D support, and international collaboration. And that is the way we've partnered with EVA or Vector 3D, and then our new partnership with Anavia from Switzerland for heavy lift helicopters. And my philosophy is we don't have to wait for us to build something when the technology is out there. We always bring it in, and then we start building from there. Otherwise, we will always be 10, 15 years behind the world. And that's why we are looking to bring into India newer cutting edge technologies that can help also the people of this country, and then help the manufacturing setup in India to grow faster. And that's what we've been doing with these OEMs from abroad. Next slide. So this is one of our flagship programs where we train pilots. Now we provide licenses along with our partners, Flight Tech Aviation in Telangana, uh, where we also place the trainees after they complete the course. We are one of the two organizations in the country that provides an extensive training with advanced applications in agriculture mapping survey and cinematography. So this is one of our projects. If you're interested, you can always show your consent in the feedback form, and then our team will get back to you. Next slide. These are our clients and partners whom we work with. More getting added to this list. India will reach the 2 billion mark in the commercial space itself very shortly, and then it's very important for young entrepreneurs or even budding engineers to take up the cause of the drone space in India. And what the IT did long back in the early 90s is what drone is going to do to India is going to make it another, apart from being the IT services hub for the world, we will also be the drone tech hub for the world. So that's what my vision is, and I share that with you. And hopefully, some of you could take up the cause of expanding the drone technology and the drone industry for the country. Next slide. Flight 100 program is something that I've envisioned, a 45-day program plus a 1-year mentorship for budding entrepreneurs, where we will help set up 100 companies and push it forward to create products and services that help. Just for one moment. Yeah, so that will help set up the entire ecosystem, part manufacturing services in very niche applications, and drone manufacturing itself, support system manufacturing, ground station infrastructure manufacturing. So we will help with all of help budding entrepreneurs set up companies in these spaces so that we become self-sufficient. Today, majorly we are importing from China still, and then that needs to stop at some point of time. This is the only way that will happen when people take up part manufacturing in itself and then take it forward. So if you're interested, you can also leave your consent for this, and the team will get back to you regarding that. So this is one of my common saying: drone applications are limited by human imagination. You can imagine something today, and that will be on a drone tomorrow. Since we're talking communication, I've always had this wish where we could build tethered systems that could act as temporary mobile towers during any of the natural calamities. Because when hurricanes or typhoons or cyclones, super cyclones hit our east coast, mostly communications go down, and then it takes a lot of time to put them up. Drones which can act as Wi-Fi hotspots or can act as communication towers. If we could have tethered systems that could fly for 8 or 10 hours, that will help in restoring communications very fast. So that's an idea that I'm putting out. Anybody wants to work on it, we'll be glad to help in that space as well. So thank you so much for your time. We will take questions. If you have questions, you can also put it on the chat, or you can unmute yourself and then ask the question. Please state your name before you ask the question. Thank you.
Hello, sir.
Yes, please.
My name is Madhvaraj from PDAT, Assistant Professor, Department
Hello,
of Technology. The presentation was very nice, sir. And my question is, this unmanned air vehicles, is it used for any passenger traveling? Is there? Or
yeah, it is there, sir.
Craft and all those things.
So what we call drone taxis or personalized aerial vehicles, we have that. There are a lot of companies around the world that is working on it. The leading tech in that space is still in China. It's called EHang. They already built a 2-seater and a 4-seater system 2 years back itself. That was in Dubai, and if in this year's Dubai's exhibition, it will be displayed. Then you have Joby Aerospace, and then other companies in Europe and US that are building 4-seater, 6-seater, 8-seater drones, or eVTOLs as we call it, that will fly autonomously. You just get into the drone, put in the destination, and then the drone takes off. So that is already being done. Companies have already got orders up to 8 billion USD for delivery of those systems. So that's a space in India that is yet to be explored, and there's scope for that.
Okay, thank you, sir.
Thank you.
Yeah, good morning, sir. This is Prabodh from MIT Tandavpura.
Yes, sir.
I was a little curious about the longest flight that an UAV has made till now. Any kilometers
in terms
or
of endurance or kilometers?
in terms of distance traveled?
It majorly, the HAPS system has flown around the world.
Oh, is it okay?
Yeah. So what happens is it flies on solar.
Mm-hmm.
So it takes off, reaches 20 kilometers altitude.
Okay.
And then it has flown for almost 3 weeks,
Nice.
capturing data. So you can take a look at that. Even on our website, we've written a blog on those systems. That is the longest flight as of now recorded on a fixed wing UAV.
Thank you. Thank you.
Any other question? We can take one more question. I have another meeting regarding regulations now. So I can take one last question before we could close.
Again, this is Prabodh.
Yes,
The potential job opportunities for the students studying right now. Can you brief the for the next couple of years or 5 years down the line? What is the job opportunity for students in the UAV or drone technology?
So one would be drone pilots. India will need almost 2.5 lakh drone pilots in the next 5 years. One. Second is you will need post-processing engineers for a lot of applications. Third, we will need technicians for maintenance and overhaul. And then we will need production engineers, the normal manufacturing setup, whatever manpower is required, we will need for setting up the entire production line, because right now we are looking at large scale procurement in the government itself. And after that, we are looking at enhanced communications. So every segment in the engineering space will look at job, because once you start motor manufacturing, you need EEE students. When you go for electronics and communication, you need EC and IS students. When we go for infrastructure inspection, you will need civil engineering students, mechanical engineering students, so they will be required for the entire manufacturing. You will need biotech students when medical delivery will happen. So you will also need pharma students who will be part of that. That's why I call drone technology a mass employer, similar to IT space. So you will need everybody to perform roles in various segments, and since it's very rapidly evolving, what I say today might not necessarily be what it will be there even 2-3 months down the line. There might be some other additional requirement that will come about. We will need fleet managers. We will need people who could do big data and analytics to understand what is the most efficient way we can use fleet. In India, if we have to put drones for agriculture, requirement is 6.5 lakh systems will need to be deployed. 6.5 lakh drones flying is a huge logistics nightmare one end and a huge operations headache as well. So you will need an entire ecosystem that will be built to support this. And that way, whatever IT infrastructure took or whatever IT infrastructure put before us in terms of job opportunities, the same thing will happen with drones. 5 years down the line, we will be looking at the drone industry as big as the IT industry itself, because of the innumerable applications that drones have been offered.
Thank you.
So I think we will close. If anybody has any other questions, you can always write us to info@jnaerospace.co.in, or you can always ping us on any of our social media platforms on YouTube, Facebook, LinkedIn, Instagram, and Twitter. And we will be glad to answer. Thank you, both the
Sir?
organizations,
Sir?
for the
Hello,
opportunity.
sir.
Yes, sir. Please go ahead.
Sir, is it only applicable for a particular domain or for the students?
No,
Or-
sir, it is not that way. It is applicable pan domain. It's even beyond engineering. As I said, you need paramedical staff when drone delivery starts,
Okay.
because how you handle blood or samples cannot be done by engineers. It needs paramedical staff.
Okay.
So even when we do emergency medical supplies, if we send a defibrillator on a drone, people will need to know how to handle it, or how to give morphine or any of that, or give adrenaline. We can't have engineering students do everything. So paramedical staff will come into picture. It will, anyways, traditional, as a business, traditional roles will always be there in accounting, in finance, in marketing. All of these roles will be there. But then extraordinary roles will also come into picture, like drone pilot, co-pilot, drone pilot instructor, drone test pilot, and maintenance staff. These 5 roles did not exist. Now that has been added into the market.
Okay, sir.
Like this, as per applications, even if you're, let's say somebody does NDT certification, we can do ultrasonic thickness testing, crack detection in concrete, we can do methane gas detection. All of this we can do with drones. I've done it. That's why I'm saying. So even if somebody does NDT, becomes an instrumentation, I don't know if instrumentation would be the right word. If somebody does NDT certification level 1, level 2, they can also be part of the drone industry.
But what is the basic knowledge necessary for to start?
Depends on what roles. If you're a drone, if you want to be a drone pilot, I would say minimum 12th pass is more than sufficient with English, because the exam is in English. So they will need to write the exam in English. But to be a test pilot and all of that, minimum graduation is required, preferably a technical degree. And for the rest of the roles, it is role specific.
Okay, sir. Thank you.
Thank you. So thank you so much for both the organizations for giving us this opportunity to present. We look forward to continuously working with you, and hopefully we will take drone technology to new heights. Thank you so much.
Yeah, I would like to also thank the JMA or the Jane Aerospace, Mr. Leo Peter Charles, for the wonderful presentation on the drone technology, communications, the future potential it holds for the engineers as well. And also I'd like to thank the other staffs of Jane Aerospace who had coordinated with both the institutions in making this talk a grand success. I'd also like to thank the management of VB Sangha, the principal, Dr. S.M. Shashidhar sir of PDIT Hospete, and also the Maharaja Education Trust in Mysore, and as well as Dr. Y.T. Krishna Goda, principal of MIT Tandavpura, and also the HODs of all the departments in both the colleges, the teaching and non-teaching staffs in both the colleges, and the students as well as the participants who took the benefit of this wonderful talk. Thank you all for being here.
Okay, sir. Thank you.
Thank you so much.
Thank you.
I'll kindly request everyone to check your chat box, wherein we have linked the feedback response document, which enables us to send you your certificates, and which will also help us send you further webinar details in the future. I thank you all for joining us for this wonderful webinar, and I thank the respective colleges for coordinating likewise with Jane Aerospace and conducting this webinar in a grand success. Thank you all.
Thank you, sir. Thank you.